Today we're going to be looking at, I will be able to set up a proportion to find missing lengths in similar figures. I will be able to determine the transformation that maps on the one figure onto another. We're going to take a good look at triangles specifically. The Regents likes to ask a lot of questions on triangles. So let's get right into it. If this would like to change. Okay, great. So in the accompanying diagram, triangle QRS is similar to LMN. They give you these measurements and they actually label them for you. They want to know what ML is. So we're looking for this guy right here. As I've suggested in the past, when you have congruent triangles, we always used to line them up and try to figure out what sides relate to each other. So I think this is the easiest way to do it still. Just line them up and see what's corresponding, right? So we want this LM here. We want to know what corresponds to LM. Well, let's go over here. LM corresponds to QR. All right, well, we know if the triangles are similar, then the sides are in proportion to each other. So LM is X, right? Okay, and I know that LM corresponds to QR, so QR is 30, and I know all the proportions are similar or are the same proportions, so I'm going to take this guy LN down here, LN, and I notice that's similar or corresponding rather to QS. So I picked for my small triangle, I'm going to pick for my small triangle again to make sure that it's the same ratio. And 7/21 should be the same as x over 30. So what I end up doing now is we see a fraction that's equal to each other, a ratio that's equal to each other. We're going to cross multiply those guys. All right. And we end up with 7 times 30. 7 times 30 gives us 210. And then we get 21x. Okay, we divide by 21, and we are left with 10. 210 divided by 21 should give you 10. I don't know why I'm not writing. 10. Okay, so we set the proportion up. We cross multiplied and we got 10. All right, let's take a look at another one. Now this one says in the diagram below, these triangles are similar. They're telling us they're similar. And which measurements are justified by this similarity? So they want you to plug all these guys in and test out which ones work. All right, well, let's see. So we've got A, B, C, A, D, E, and this is what's corresponding to each other. So they're telling us AD is 3, AB, this big guy here, is 6. So those should be proportionate to each other, a little triangle over big triangle. And then AE is 4, little triangle over AC, big triangle. Are these equal to each other? Little triangle over big triangle. Well, no, because this is 1/2 and this is 1/3. So those are not equal to each other, so that doesn't work. All right, well, let's try another one. That does not work. Cross out number 1. How about 5 for AD? And then AB is 8, meaning that this big guy here, 5 plus 8 would give us, I'm sorry, AB is actually 8. That's fine. And then AE is 7. AC is 10. AC is 10 is 5 over 8. The same thing as 7 over 10. Well, no, I can't reduce either of those, so that doesn't work out. All right. Looks like we're on a good track here. 2 did not work out so far. All right, and then these are all the same sides, so I'm just going to test out 3 over 9. Is that the same thing as 5 over 10? Well, no again, because this is 1/3 and this is 1/2. So that doesn't work out. So it's got to be 4, right? Well, let's check it out. 2/6, it should be equal to 5/15. And what's 2/6? Well, that's 1/3. What's 5/16? Well, that's also 1/3. So ding, 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 we've got our winner. It's number 4 down here. And that's because these sides had to be proportional if these triangles were similar. All right, and that's really it. You're just setting up the sides to be proportional if you know that they're similar. So you guys are going to do these 2 questions for homework, or classwork rather, but I want you to notice something. They say they're parallel, and if sides are parallel and they look like this in the triangle, then this little triangle here is congruent to this big triangle here. Okay, so in this triangle, they were similar. That meant DE was parallel to BC. And if they had told you that they were parallel, you could also say they're similar. So it's like that converse is true. And the same thing down here, they're telling you RS is parallel to QT. So you know that the 2 triangles here are in fact similar to each other. So little key, you got to watch the video if you want to be able to do the classwork questions. So thanks for tuning in and good luck.